in this question, we have a 50-kilogram teacher steps off the balcony onto a platform supported by a spring. And then he falls, and right before reaching the ground comes to a stop, and then connects the platform to a hook so it doesn't go anywhere. Later, he comes back with an additional 20 kilograms, steps on the platform, and then the platform will rise to a certain height. So the question is, how far away is the platform from the balcony when it rises to that maximum height? So we're going to use conservation of energy to solve this problem. So let's split the problem into two. The first problem, we initially have the spring at the balcony at the very top carrying 50 kilograms. It is currently 100 meters from the ground. And then at some time later, it falls all the way and comes to rest right at the ground. Okay, so let's analyze this situation here. So we'll use conservation of energy, where the total energy, let's call this part A, situation A, position A, whatever, at A must be equal to the total energy at B. Let's call this picture B. So at A, we have gravitational potential energy, which is the formula mgh. And at B, we have elastic potential energy, which is 1/2 kx squared. Alright, so we know mass is 50 kilograms. We know what G is, that's 9.81 newtons per kilogram. And we know H, which is 100 meters. And that's going to equal to 1/2 times K times X, which is the displacement from equilibrium, which in this case is also 100 meters squared. So we can use this to solve for what that spring constant is, or force constant, for the spring that's being used here. So when we rearrange to solve for K, turns out we have these cancel, and if we multiply both sides by 2, we'll have 100 cancel with the other 100. So we're just left with K equals 9.81 newtons per meter. Alright, so we know what K is. Let me write that at the side. K equals 9.81 newtons per meter. And let's go and look at our second situation. So in our second situation, let's look at point A, where the spring is all the way down at the ground, where now we are carrying 70 kilograms. And then at B, it comes up to some maximum height. Now this maximum height is going to be, let's say the balcony is here, some X distance from the balcony, or from its equilibrium position, because that's where it's originally being held. And it will be, since it's 100 meters from the balcony to the floor, it'll be at a position that is 100 minus X meters from the floor. So if we apply conservation of energy again, where total energy at A equals total energy at B, here at A, we only have elastic potential energy, so 1/2 kx squared, where we know what K is now. And at B, we only have gravitational energy, mg times 100 minus x, plus a little bit of elastic energy, 1/2 kx. And let's call these x's prime, just so we don't confuse it with this x, which is 100 meters. So prime squared. Alright, so the only thing left to do is to solve this equation for x prime. Now since k is the same value as g, I can actually cancel it, because there's a k or a g in each term. And if I multiply both sides of the equation by 2, we get x squared equals 2 times mass times 100 minus x prime plus x prime squared. Now the mass is now 70 kilograms, so we have x squared, and I can bring this to the other side. So minus x prime squared equals 70 kilograms times 2 would be 140 times 100 minus x prime. So the original x was right here, which is to the ground. So we have 100 squared minus x prime squared equals to 140 times 100 minus x prime. This is a nice difference of squares, so I can have it as 100 minus x times 100 plus x, which equals 140 times 100 minus x prime. Now, of course, x being 100 is a solution because that's just it right back on the floor, but that's not the solution we're interested in, so we cancel that out from both sides, and we get 100 plus x equals to 140, or subtract 100 from both sides, and we get x equal to 40 meters, or our answer is C.